Step response, as the name implies, this is the response of an LTI system to a unit step input. What is the output corresponding to a unit step signal? That means what happens, how the system behaves when there is a sudden change in the sudden jump in the input. Now, can you tell me, is there any relation between this unit step response, the step response and impulse response of a system? What is the output here? Suppose the impulse response of the system is ht. What is the step response?
Integral of h of t from minus infinity to t.
It is ht, means ut convolution ht, isn't it? Is it that? If the impulse response is ht, if you are giving ut as the input, it is ut. So if the impulse response is ht and you are giving an input ut, the output is ut convolution ht, isn't it? Now, as in yesterday's class, we discussed about this convolution with ut. What is convolution with ut? This is called the step response of the system, and we denote it by st. ht is, we denote the impulse response by ht, and this is st. So what is this convolution? You convolve any function
Integral
with
of h of t from minus infinity.
It is an
to t.
integrator, isn't it? So it is, if you do this convolution, you can write also like infinity minus infinity to infinity h tau ut minus tau d tau. This is a unit step function. This is greater than, this is 1 only when this argument is non-zero. Argument is greater than 0. So for that condition is integral minus infinity to t h tau d tau. Is it? So that is the relation between the step response of a system and its impulse response. Step response st is integral minus infinity to t h tau d tau. And this we can also prove from the properties of linear time invariant system, isn't it? What is the relation between delta t and ut? What is
ut is equal to integration minus infinity to t delta t.
ut is d tau, delta tau d tau. Okay, and in I think Tuesday's class we discussed about an important property of delta function. If you give, let's say, xt to an LTI system and getting yt as the output, if you are giving x dash t as the input, what will be the output? X dash t?
Y dash t.
This y dash t. It is not only x dash t. If you are giving integral of xt as the input, output will be what?
Integral of y.
Integral minus infinity t y tau d tau. These are important properties. I have derived this in Tuesday's class. So can we use this same result using these properties? We know that if there is a LTI system, give delta t, you will get ht, and give ut as the input, we denote it by st. Since this is the integral of this, st is also integral of ht, isn't it? Is it that? From this property.
Yes, sir.
Okay, so that is the relation. We can summarize that. St is integral minus infinity to t h tau d tau. That is the step response. That is the integral of the impulse response of the system. And we can also write ht is derivative of st. Okay, so that is the relation between the step response of a system and impulse response of the system. And what is the corresponding relation in the case of discrete time system? If you are giving delta n, that is discrete time impulse as the input, let us denote it by hn. Then un as the input, I am denoting it by Sn. What is the relation between this?
Summation minus infinity
It is
to
summation
n
from,
hn.
instead of integration, it is summation. So it is summation minus infinity to n hk. Okay, this is an accumulator. In the case of continuous time system, it is integration, and here it is accumulation. Okay. Now what is hk in terms of sk? Here it is the first derivative. So can you find sk from hn from this?
SK minus SK minus.
Because
Sn
it-
minus Sn minus.
because you can we can write this as hn plus what? Sn minus 1. If you take the summation from minus infinity to n minus 1, that will be Sn minus 1 plus Hn, isn't it? So this is Sn minus 1. Here it is the first derivative, and in the case of discrete time signal, it is the system, it is the first difference. That is the corresponding relation.